geez, you put a pressure gauge on it, and you have a discharge valve. And the first thing we can do is we can test is if the pump is meeting shutoff head. And shutoff head, to me, tells us a lot, because you can tell if your pump is worn. Because if you go towards shutoff, which is like right here at the end of the curve, and you turn the pump on, make sure everything's full of water, everything, and you shut the valve down while it's going. And when it's all the way shut, you take a reading on your pressure gauge, and you can compare it. You know, once you have this curve, you could compare it to where you're at in relation to this, you know, minus your suction lift. And if it's pretty close or right dead on, your pump's probably in pretty good shape. But if you're off, you know, 15, 20 pounds, it could mean that your pump's worn out some. So that's a good indicator right there. And then what you can do too is go ahead and open your valve up like another quarter turn, take a reading. The only thing is it makes it tough on this, because you can see how flat that is right to this area here. It's basically no change in pressure from about, you know, this 500 gallons all the way to shutoff almost. So it's going to be almost the same pressure, but as long as it maintains the same pressure. And then the other thing that's nice to do is if you have an amp meter, while you're taking these pressure readings, is to have an amp meter on it, so you can also see what your motor loading is. Because when you're back here, like you know, we say you have 60 horsepower line. Well, back here you should have, you know, maybe a 30 horsepower load or so, and that should show up in your amperage. And then as you actually go out on the curb and you keep opening the valve, you take your pressure readings and you start checking your amperage. You'll notice once you hit this point, you're right at nameplate amperage on your motor. And then as you move out further, you're going to start going into the service factor load. So this is a good way you can kind of tell what your motor's doing, make sure it's in good shape, and you can see if there's any discrepancies between what it's supposed to do and what you see here. Any questions on that? Okay. So, and the thing is too, and I should have mentioned, if you have this curve, you can actually, when you're out there in the field, you can actually plot your pressure readings and just kind of analyze it. And if you're not sure what you're looking at, you could take it to something like WaterTech here, and they could tell you if your pump's looking good or it maybe needs to be rebuilt or something. So. All right. Okay, this is more or less what I was just talking about here, about checking your pump. I already went through all these points pretty much. And again, like I said, you know, if you're operating all the time to one side of the best efficiency point or the other, you might want to look at changing a pump, or, you know, you could put a variable speed drive on and maybe bring it back into a better efficiency that way. And so here we are, we're talking about VFDs now, and you know, is a VFD a solution maybe to help get the efficiency you need out of your pump? And sometimes it is. Sometimes, you know, you might have a pump that's running higher pressure than you really need, and by putting a drive on, it's going to move it back down, maybe not use so much electricity, and you could run it, instead of 60 pounds, you only need 50, and you can turn down the RPM, and it will operate it at a better design point. And so what I basically am saying here is there's like the pros and cons of putting a VFD on. And so like a VFD can reduce your power consumption. And the main thing there is too, it can, like we talked about, when you throw the switch and start your pump, if it goes all the way over, well, the drive has the ability to you can set an amperage range, and it will won't let the pump go into that mode. We actually have a pipe fill mode on the drives that will allow a time for the whole pipeline to fill up, and then the drive will ramp up to its operating speed. But it will never exceed the nameplate amperage of your motor.
Excuse me, Mike?
Yeah.
You might want to just mention how a variable frequency drive, VFD, what it is and how it
Sure. I thought that was someone else's topic. No, actually, a VFD, I mean, if you don't know, that's basically it does what it says. It's changing the frequency of the motor, because all our system, if we operate on 60 hertz, and what the drive does is change that 60 hertz, and when you reduce the RPM, it's changing it to 55 hertz, 50 hertz, all the way down. So that's what it's actually doing. It's changing the hertz, and that changes the speed of the motor. And so anyway, as I mentioned, you have the pipe fill mode, then we have the adjustable speed, so we can tune it into your system more. Or if you have multiple conditions, you could have it do 2 different conditions pretty easily. We see it a lot more like we have hilly terrain, like when you're using center pivot irrigation, and then they have terrain that's not very even. You got one side's going up a hill, the other side's going downhill. Well, that's where a drive really works good, because it will compensate for the high side and the low side. And the other aspect now then you have with a drive too is you can do remote monitoring. You can lay on the beach of Hawaii and look at your phone. You can see exactly what your irrigation systems are doing through the telemetry and PLCs and all, and you can pretty much tell everything that's going on with your system from far away. I mean, I've been into some farmers' pickup trucks. They have the regular laptop computer sitting there. They got every pivot on their property, and there could be 100 pivots there, and they can tell what's going on with every single one of them. So, but anyway, now the cons of a drive is that upfront costs are expensive. But and I forgot to mention one more pro on I know up here you have quite a bit of areas too where you only have single phase power, and so sometimes if you want to go to a larger pump, by utilizing a drive, we can use it as a phase converter. So we have that ability. I think, is it through 30 horsepower, Reed?
Phase converter, yeah, roughly.
Yeah.
It's on a utility.
Right. But then also, a drive doesn't always address all the scenarios that are out there in your irrigation system. Like I said, sometimes 2 pumps could be more efficient than putting a drive on, because you only have 2 points you have to hit, or 2 areas. So you can pick 2 real efficient pumps and take care of that. And then you could do the thing with the big thing about drives is they reduce the power on startup. So, a lot of places when you threw the switch, you got these big demand charges when you threw your pump online. Well, the drive eliminates a lot of that, because now you're starting under low amperage, and they don't charge you as much then for that. So, and then the other thing is, let's say if there was a technical problem, the drive failed or whatever, well, who's going to service it? Can they get out there right away, take care of me, get me back online, and get water on my crops? That's kind of a big deal. But that's becoming not such a bad, not that hard to do anymore. I mean, some people like WaterTech, they got people that know drives and stuff too, and there's a lot of people out that are getting more and more knowledge about how to operate them and stuff. Yeah.
Is it possible to have multiple VFDs on one system?
Oh yeah.
Okay.
Yeah. No, that's no problem.
They work together. They don't fight.
Yeah, we have what we call like a cascade controller, and we can operate numerous. I mean, we do a lot of these big booster stations, like we put together for a lot of cities. Well, they'll have like these vertical multi-stage pumps. We'll have 3 or 4, and so it's just all on demand. So as more people, like in the morning, everybody's flushing toilets, taking showers, those pumps sequence on, and then sequence off is how they do that. Yeah. So now we have some do a lot of these for a lot of the orchards in Eastern Washington. They do a lot of these ponds where they have 3 or 4 turbines, line shaft turbines, and they sequence those on the same way depending on what they're doing. But a lot of those orchards have got like 4 irrigation systems on. They have not only irrigation, then they have cooling, you have chemigation, and then you have frost control. So, and those all take different amounts of water. And so with the drives, they're able to do all those with one system. So here I kind of wanted to show you this is a multi-speed curve I did like on that B4 JPBH. And it's right there. And so what I did, I basically took from 1770 RPM, and I was just showing you how, by changing the speed, you can see how it kind of, how our volume and our pressure starts to change. And the thing is, if your efficiency lines are up here, they're all kind of glided together. So it's showing how as you slow it down, that line there is the bottom 1200 RPM or whatever. that's your 1770s over here. So you can see as you slow it down, you're basically sliding back this way with the pump performance. So you can see if you have a requirement down over in this area that's lower flow, you can hit that with the drive. And then the other thing I wanted to show is basically like here's your horsepower. You can see how your horsepower changes, and that's what about horsepower. They're even talk about sometimes people want to overspeed their pumps a little bit. And there's kind of a limit with most motors to what you can overspeed, and the trouble you have too is when you up the RPM, it goes up as a cube of everything. The horsepower goes up very, very quickly. So it's normally not done, but I mean, in some instances it is done. And then that bottom line is I'm just showing the NPSH, but that doesn't seem to change too much. That stays pretty close together. So, and then you see that red line over here? For that pump, we have what we call a minimum flow. And that is more or less there because if you get beyond to the left side of that, what happens to your pump? It can get noisy and stuff because what happens, you start to recirculate the water within the pump a lot of times. It just doesn't have enough flow to keep everything full, let's say, but the water starts falling back on itself is what happens. And that's an area you don't want to operate either. Because I mean, how many times it'd be nice to have the pump that does everything. A lot of people want to do low flow, high flow, but you just can't do it with one pump. It's just too hard to do. So, oops. Okay. So I want to talk about, factors that in pump efficiency loss, it's going to happen. So basically, one is like, if you have a old pump out there and it's, it could be very, who knows, 30, 40 years old. I know how some of these, I've seen a lot of pumps out here that are pretty old. It's amazing how durable some of these pumps are, but the efficiency of a lot of those pumps is probably pretty low just due to wear. But anyway, big factor of loss of efficiency in a pump is just abrasives. If you pump dirty water, that water going through the impeller seems to remove material, and then your wear ring clearances open up, and you're going to see a pressure loss. And then the other thing of what happens is your pump wears due to abrasives. When I show you that curve, it will tend to actually move to the right. It'll actually want to pump more volume, but it's going to do less pressure. But it's recirculating water within the pump itself too. And then also, you can start to develop vibration. You might get, I've seen where you get a rock in the vein or something happens, something gets out of balance or just starts to get too worn, get vibration. And the other cause of losses is you're on your suction side, like with your strainer. If all of a sudden you might get cavitation because you got a lot of debris around your suction screen, and that's causing a strain. So it's all of a sudden now it's going to get noisy, it's going to rumble, and that's what cavitation sounds, kind of a rumble in your pump. And in fact, I had a good example here of cavitation. If you want to pass that around, it just kind of shows what happens. It's just, I'm not sure if a lot of people kind of misunderstand cavitation. Some people always think it's like entering air or whatever, but it's actually the point where, like when you watch a pot of water boil, you see a bubble form at the bottom, it gets big and goes to the top. Well, that's the water turning from a liquid to a gas. Well, in cavitation, what happens on that pump is that it's turning in from a liquid, it's going to a gas, but then it's going over to a high pressure area. If you see where the erosion was in an impeller, it goes back to high pressure, and that bubble collapses. And when that bubble collapses, it has like it collapses with such force that it actually removes metal out of the impeller. That's what cavitation is. And that's why you get that pitted damage in your impellers. If you start seeing that, that means you've got cavitation happening. And, something has to be addressed, whether it's, like suction screen issue or something's changed and your water level's down lower. Now the pump has to pull at a higher lift. You're hitting that point where it's going to start to cavitate. That could be an issue. That's going to affect performance. And And then once you get this kind of damage, like you'll see on this impeller here, it just doesn't perform as well either. You know, of course, that one's probably a little bit extreme. And then it happens different ways. You can get erosion just in the inlet, or like this one here has it on the vane tips. Okay. And then as far as the motor goes, you know, if you're just checking your amperage or what, if you notice even at normal operating ranges, it still seems to have high amperage. You got vibration, maybe due to the bearings or just mechanical wear. You notice the motor is very, very hot, which is really attributed to probably the high amperage, and then just vibration in general. And then on the irrigation system, that's kind of a big thing, because there's a lot of things you can do in your system that can cause inefficiencies in the pump. And number one, like I have there, is like worn sprinkler nozzles. If you got, you know, 7/64 nozzles out there on your sprinklers, and all of a sudden, if you went out there and checked it with a drill or what, and they're, you know, a couple sizes bigger, that means you're pumping that much more volume. So you can see on that pump curve now, all of a sudden you've moved a little bit farther on the right side. You're pumping a lot more volume, and you might not be getting the pressure now either. You know, you might notice a bit of a drop of pressure, but your volume's increased. So it's important to check those nozzles, especially if you're pumping from an abrasive water source. You probably would see that happen more. And then I've seen it too. Then you have people out there that, well, they just happen to have some other nozzles on hand. They're using different size nozzles. And so sometimes it's hard to tell what normally it's pretty easy to tell if you have, you know, like a certain sprinkler size, so much that size nozzle, then you know how many gallons per minute you should be pumping at that pressure. But when you start mixing it up, then you have no idea where you're at as far as volume and pressure then. And then the other thing is leaks, like on the main line. I mean, I remember you drive around the field sometimes, especially on the aluminum irrigation pipe, and you see water spraying all over the place, and they wonder why the performance is off in their pump. Well, they just need to fix their leaks. And then if you do any kind of system changes, you do additions, maybe subtractions, you're changing the type of sprinklers you're putting on, that all can affect the efficiency of your system. Because maybe you went from sprinklers to drip. Now, you know, that pump you might have to reevaluate. Is that really the right pump for that job? It probably would work, but you're maybe wasting a lot of energy. It's a lot bigger than what you need. So that has something to be considered. And then the other thing, especially when you're, like, let's say if we're making a system change or you're putting in mainline, like I use that 750 gallon as a point on a lot of pumps. Well, when you're looking at putting in mainline pipe, for 6-inch pipe, your friction loss at 750 gallons is kind of borderline. I mean, you can go either way with it almost. You think, well, should I go to 8-inch? Or should I, well, but 8-inch costs so much more money, I think I'll just stick with 6. Well, but if you're going like a mile or half mile of line, your friction loss, you've got to now get a pump with enough horsepower to compensate for that friction loss. So you have to weigh, is it better to spend the money on 8-inch pipe, or should I buy a bigger pump? And that's going to use more energy, more power. And so what's my payback going to be? So those little things you need to look at when you're changing your system or putting in mainline is, don't just look at the bottom line at first. You got to look down the road a ways to see what it's really going to cost you. You know, because, you know, with power rates and stuff too, I don't know if they're always going up to or not, but just something to look at. And this is some kind of a topic comes up a lot. You know, people talk about, you know, the old motors. You know, you had the old cast iron frames. You look at an old 5 horsepower motor and it was like this big, you know, and the new ones were real tiny. And, but the little motors, you know, they had a lot of cast iron. They had big windings, large openings for good cooling. And that's why a lot of those motors, just when they ran, they didn't feel that hot. But in reality, you know, they weren't probably as efficient as the new ones, but since they've now, with the new motors, they've condensed the size down. So most of that heat now is going to the shell of the motor. So it's not that it's running really hotter, it's just that you're seeing more heat going to the shell of the motor. And, but the thing is now with these new efficient motors explained before, they've got the new high grade copper wire. They've got better insulation, so they can really handle that heat a little better. And you know, and the thing about a lot of the new motors now, especially like I'd say 30 horsepower and below, most of them have steel or aluminum frames. And that's why you feel a lot of heat on those too, in those steel frames. And as I explained before, the standards on, well, that was supposed to be 2016, but that was the new efficiency standards that they had to go to, and then just the improved wiring. Okay, and then as far as motor replacement, I mean, it's kind of a tough one there. I mean, it's just a matter of, you know, your age of your motor and you know what you're operating. If it's high amperage or what, then it's something that might need to be replaced. And here's the deal about rewinding motors too, is that you can, when you get a motor rewound, is that normally they'll never be as efficient as they came from the factory, because they just can't wind the windings as tight. And right now too, the breaking point, if you want to rewind a motor or buy a new one, is about 30 horsepower. If it's 30 horsepower and smaller, you probably want to buy a new motor. It's not really cost effective to rewind them. All right. Okay. Here I want to talk about, like, you know, like the pumping, you know, rebuilding versus replacing a pump. But, and I know, you know, we sell Berkeley. We even sell Cornell. That's why I kind of use them for example here, is like, you know, a pump is basically pretty simple. There's just impeller, wear ring, packing, maybe, or a mechanical seal in it. And there aren't a lot of parts, but they do charge a lot for some of those parts though too, especially if you have a large pump. And so anyway, if you needed parts like an impeller or something, it's probably fine. Go ahead and replace the impeller. But if you need something more like a volute case or a bracket and an impeller, then I'd suggest we get the pump and kit. And if it was a Cornell pump, you probably have to just buy what you need, because they don't really offer a kit program for theirs. And the other thing you have to look at is the age of your pump, because there's a lot of, I mean, like even like Berkeley, we have these old A-line pumps. There's quite a few of them out there still, but if anything goes wrong with them, there's no more parts available. They're obsolete. So if your pump is really old and you find out there's no parts available, you're probably better off just getting a new one. Because if it's down the road where the pump fails, you know, you're going to have to, you can't get parts. And maybe the model you need may take a few days to get, and you got crop out there, and you know how it is. You know, you need it right away. Just like those dairies with all the cows, you know, they need water right away. So, any questions on that then? All right, well, basically, I mean, that's pretty much what I had to cover here. And so, in conclusion with all this, like I state here, you want to start with a good plan with your crop or whatever you're going to do. Think about, you know, your future needs, what you're going to do in the future with your system, because then you can make sure you're designing for not only now, but maybe down the road, what you want to grow or change or whatever in your system. And then what I mean by engage the tools of technology, well, you know, let's look at a VFD maybe for your system, or some other kind of technology that might help make it easier, reduce some labor. You know, it's always tough too when if you have to go out and drive around your property and check for leaks, or just see how the irrigation system's doing. Well, if you automate things, you can eliminate a lot of that travel time around your field. And, you know, well, at least, or even employees too. So, anybody have any questions?
Any questions? Mark, you always like to finger off us.
A lot of times we get asked, people want to oversize their pump.
Mm-hmm.
Bigger motor, better, not necessarily better efficiency, but there's some comfort in knowing that if the pump starts to fail, that you have a little bit of cushion.
Yeah, you're right, because you do want to allow for wear over time, and that's if you try to cut that pressure and sizing that pump right to the exact point on the curve, from there on, it's actually, as the pump wears, it's just going to go down. So if you stay above it, 10 pounds, usually a good point to go 10 pounds above, that would allow for some of that change. And then how it is sometimes in designs, if you make some small change or something, it won't affect it that much either. So, but and the thing is, people never complain when they have too much pressure. Usually, they usually don't complain about that too often. So when they don't have enough is when they're going to complain to you.
Something else too, I think you mentioned it, is a lot of people mentioned that their pumps are too hot to touch.
Yeah, and that's like I mentioned about the steel shells and the more compact motor, that heat's going right to the shell. The older motors had larger air gaps and they had a lot of cast iron frames, bigger, so they could dissipate more of that heat over a larger area. And these new motors are just because of how tight they are. Mm-hmm. Yeah, and the air gaps are really small now too. But, it still has to be within reason. I mean, the one gauge you have to look at is always look at the amperage. If the amps are right where it needs to be, then you're fine. If it's over, then yeah, you probably do have an issue somewhere then. And an amp probe is something easy to have because that just, you clamp it around the wire and you can just see where your amps are. So it's a pretty easy device to use. And like when you're measuring like pressure and you take the amp reading, you can really see what your motor is, how good it's working. Is it getting up to load, or are you way under, or are you over? So it kind of, between the two, you can kind of see what's going on.
So an amp meter and a flow meter, or an amp meter and a pressure gauge?
Well, pressure gauge, just compare with a pressure gauge. I mean, a flow meter would be good too, because a lot of times you can go to the curve and look at that pressure, and then look at if it said like 40 pounds, you go to that curve, look at 92 feet, let's say, and that should be what your volume is at that point. That's what you should be pumping. But if you know you're not, then man, there might be something else wrong. Maybe your strainer's plugged or something like that, something in the pump.
If I have an amp gauge, and I get a reading, but I need to know if that's a good reading or not. Is that?
Well, you look at the name tag on your motor.
Well, I have a submersible. So
Oh, well, okay, yeah. Now a submersible is different because you need to have the book that has those amp readings in it then. But we can get, you're right. I mean, actually, a lot of this pertains, I was talking most about centrifugals, but with submersibles, it's kind of the same thing, but yet you don't have that motor in front of you. And the other thing you have the resistance of the wire coming up to the top.
right,
So you have to account for that on some of the resistant readings or the amp readings you take too. Mainly that's just for resistance though, but you can tell on a submersible where you're at. Think about a submersible, it's even like Bill was talking about wells, and with submersibles you have another problem there because especially when you have iron or iron bacteria, if it starts to build up on the motor, the problem you have there is submersibles are very susceptible to heat, and if they're not getting proper cooling and that water's not, like he said, coming from the bottom of the well flowing past the motor, it's very important because if that water's coming, like you said, you're down on the screen with the motor, that motor is going to go after a while. You're just not getting, you're not getting water from the bottom going past the motor. It's coming in from the side then. So that's why it's important to be above that well screen. And the other thing with submersibles, I mean, out of sight, out of mind, but then sometimes, you let them sit for quite a long time. You go to start them. Sometimes they don't start because they start plugging up with rust and stuff, and it takes quite a bit of torque to break them. Sometimes it helps to reverse the lead, see if you can go back and forth with it. But a submersible is the same thing. You can look at the curve, do the same reading at the top of the well with a pressure gauge, and just see how that compares. Yeah, and submersibles, most of those are high speed. So if you do have abrasive wears, usually they wear out a lot faster because of the higher speeds too. So, of course, you guys have clean water, not too much sand here. You have a lot of sand?
I understand.
Yeah. There you go. No.
Well driller did it right.
Yeah, that's right. That's right. All right. All right.